Python for data science. So the first thing that I would like to do is to understand first how Python is doing in the computing world, in this, not in the computing world per se, but in the scientific computing world. Then we will come to data science, because we all know that Python is the most important language in the data science world. But in the scientific computing world, we know that there are other languages also. So there are essentially three categories of languages in the computing world, and at least the modern languages. One set is called the compiled languages, and we know the example, the big players in the compiled languages are Fortran, C, and C++. By the way, stop me if you don't understand something or anything. Anytime you want to stop me, please do and ask me questions. And I must say that I'm not an expert, so I may not be able to answer right away all the questions that you ask, but I will try to do my best in the next lecture. Then you have another set of languages which are called interpreted languages. Okay, so they are really different. They use different strategies. Now, the important part is that all the interpreted languages, as we go through, you will understand, they all the interpreted languages. Let me see whether okay. So they actually don't. They are not very independent, in the sense that they don't use only their libraries. They actually try to use either Fortran, C, or C++ libraries, and they are only use themselves as the driver language. That means you have C, C++, or Fortran libraries, but the main program is not written in those languages. The main program is written in the interpreted languages. So in order to do that, those interpreted languages must be able to connect to the compiled languages very efficiently. Okay, so that's the whole point. And that is called the extension API, if you can see that. So there are, for each of the interpreted languages, there are extension API, which actually connects the compiled languages. That means the libraries. Also, there is another very important use of these interpreted languages. So if you have an application which is written in C++, we know that it's not really very easy to use that application in using C++, because C++ is a rather rigid language. So what you can do, you can take one of those interpreted languages and embed that language, that means the interpreter itself, inside your C++ application. Okay, and then from the outside world, when you try to use that application, you don't directly connect to the C++ world, but you connect to that interpreted language. And we know that the interpreted languages are very flexible, and those interpreted languages in turn will connect to the C++ world to do whatever you want to do. So this is why the interpreted languages are also very, very important. And of course, as you will see, they are Python is one of those interpreted languages, and it is the most popular of all languages right now. Okay, so the compiled languages use static type. We'll not discuss much about the compiled languages in this course. They are absolutely fast, they are blazing fast, and that is why they are needed. And the portability, which is a very important thing, whether I can give you my application and you can directly run it, is called the portability. And for these compiled languages, the portability is at the source level. That means I cannot give you my compiled language application, which is an executable, and expect that you will be able to run it. In order to do that, we should have exactly the same architecture, same kind of compilation environment, and so on. But at the source level, I can pass my program to you, and you compile it yourself on your architecture, on your operating system, and it will run. On the other hand, the interpreted languages, they don't use, I mean, we'll see also exceptions. They use dynamic types. They are portable in the sense that you don't have to compile them into executable. So you just take the source code itself and run it. And when you say that they are portable, that means on each such system, there is a virtual machine. For example, in case of Python, there is the Python interpreter, which is a virtual machine, which will be running on each system, all varied with different architectures. But that virtual machine should take care of all the references of the architectures running on different systems. So if I give you the source code will run because the Python interpreter, of course, provided the Python interpreters on each system are the same, will be able to run it. So that way it's portable. We call it the interpreter languages are portable. However, the drawback is that because of the nature of interpretation, they are very, very slow compared to the compiled languages. And the other things we have already discussed, they are embedding, scripting, and interface too. So now historically, after the first language, which interpreted language which was used in the computing world, I mean, majorly was in the CDF experiment, which is called TCL, TCL, TCL. Okay. And then came another language called Perl, which was not used very extensively in the scientific community, but it used to be a very popular language. Then came Python. Okay. And Python slowly started and became a monster today, as we will see. Python has another added thing, which is called the byte compilation. That means when I say that I have the Python source code and I give it to you and you run it, it is fine, it will run. But Python has another extra step where the Python, when Python, okay, we'll come to that. So just keep in mind that it's called byte compile. We'll see what byte compiled is. Then you have the other language, very major language called Java, which sits in between the two. Also, it is the major language which introduced the byte compilation. Once again, Java source code has to be compiled, but you don't compile it into executable or binary. You compile it into something which is a string of bytes. And then there is a virtual machine which will interpret the string of bytes. So in that sense, Java and Python are now exactly the same. Now, how you make your byte code, okay, will let you execute your program either faster or slower. So in that sense, I think Java is slightly faster than Python. Okay. Also, Java can access C, C++, and Fortran. That's why I put this, and this is done with something called a Java native interface. Okay. Once again, they are not very important at this point, but Java is very secure. Java is portable. We understand that you can just take the Java byte compile. For example, if I don't want to give you Java source code, because Java is an industry language, nobody wants to share the source code, I can give you the byte compile code. Okay. And then you have the Java virtual machine, you can interpret it. Okay. So there are more languages. Then Java can also be used from Python or other interpreted languages. So Java has the same stature as C++ or C in that sense. Okay. Because Java is also a big language. On top of that, like there are many interpreted languages like the TCL, Perl, Python, etc., which are written in C. There are also many other interpreted languages which are written in Java. And these are called Bean Shell, Groovy, Jython, etc. So Jython, for example, is a Python incarnation which is written in Java. It's exactly the syntax, etc., will be exactly like the C Python, but it is written in Jython. And now it is not really very important, but 20 years ago it was important because Java was the only language which has a very robust and powerful graphic user interface. So at that time Jython was actually gaining a lot of popularity over the C Python, but now I think it is more or less dead, but they're there. Okay. Then we know there are more interpreted languages. You might have heard about JavaScript, which is for the web, the client side. There PHP, which is again for the web, but for the server side. And of course, all of you have heard about R, which is for the statistical analysis. Okay, so all these are very nice, but then all these languages are pretty old in the sense that almost all of them are 20-year-old. So do we have any further improvement in the computing world? So yes, we do. So we have to keep an eye on at least 3 more languages. So these languages are called Julia and Go and Rust. Okay, at least Julia and Rust. Okay, so Julia is a very interesting language, although it has not shown its full potential. It is a very interesting language because Julia is as easy as Python. We all know that Python is so popular among the students, even from the very beginning, that because of its simplicity. So Julia is something which is also very simple as Python, but it is very fast because it is not byte compiled, it is actually compiled to machine code, and this compilation is called the just in time compilation, or JIT. That means, I mean, I don't think it's a very useful thing. For example, for Fortran, C or C++, you have two steps. One step is that you compile it explicitly, then you run it. In the case of Julia, you will write your program and you will just run it. But in the very beginning, just before it runs, it will compile that code into machine code and then run. Okay, so this is something called a just-in-time compilation. And there are two more languages, Go and Rust. Rust is now, if you Google, and you'll find that Rust is becoming the most popular language in the last 5-6 years. Okay, and Rust is a compiled language. It is as fast as C, so we cannot say more than that. Okay, and its memory model is the best in the market so far, but it's a complex language. It's not that you can learn Rust in 2 days. I mean, you can learn Julia and Python in a few days, but Rust will take a long time. But it has a totally, not totally, but very different syntax from the languages you know, like C or C++. So in that sense, Rust is difficult, but Rust is very powerful. And slowly, Rust is actually either replacing a lot of Python from places, or now instead of relying on C or C++ libraries, Python has started to also rely on the Rust libraries. That means, again, the native interface from Python to Rust. So when you write Python, some of the in many cases, one example is very obvious. For example, you have the pandas is actually, the basic part is written in C, maybe some C++, and you have the Python with which you actually use pandas. But now Python also has a very efficient interface to a Rust library called polars, okay, which does the same thing. That means for data frame, pandas is one data frame, polars is another data frame. So Python is using both, and slowly we'll see that polars will be replacing, for big data analysis, polars will be slowly replacing pandas. Okay, so that completes our survey of the computing language in the scientific world. And I think you have also understood which will shine in the data science. We know the C++, of course, all the backends are still written in C++ for data sciences. Java is there, but I don't think beyond the industry anybody is using Java. And on the right hand side, on the interpreted part, you have Python and you have R. The others are not very important for data sciences. Julia is slowly picking up. Okay, but today is not the time to talk about Julia. Maybe next time I'll talk about Julia, and you should keep and watch on also Rust. Okay, so popularity of Python, I think this you already know. You can see that you can see the TIOBE the index, where Python is still slightly high. I mean, not slightly. Into 2024, it is much higher than any other languages if you look at the peak. Okay, and you can also look at how historically it has gained popularity from 2015 or 16, or maybe from here. I think it shows like 2018. It is monotonically increasing to dominate all other languages. Okay, and you will see that Java is more or less steady. It's slightly gone down, and the reason is obvious, because it's industry supported, so it cannot really go down very drastically. C++, I think C++ is also gaining once again with the modern C++. Again, it is not part of the discussion for this course. Okay, and the green one is C, and C is also doing very well, because all the embedded software are still in C, and there are many Internet of Things and all other stuff. So these are the major languages, and we all know that the most popular language, although it is not there, is Java, still JavaScript. Okay, but here in this index, JavaScript is not shown to be the most popular one, but it is because of the web development. So if you look at the pie chart, you will see that Python has 20 in some other index. It's not the TIOBE index. It's another index. It's Python 28%, Java some percent, JavaScript is quite prominent. And then you go slowly and you see that Rust, which I talked about, is gaining slowly, and it is only 2.23%. And Go is also the same. Okay, and Julia has not yet come into picture at all. It is in the others because it's probably less than 1%, but they are slowly picking up. Okay, so I'll stop all these things now. Now we can go to Python at a glance. Let's again. So as I said, I want to give you first a very basic idea about how Python should work and how it is in the wider uh, picture. So Python is a dynamically typed and dynamically typed, loosely bound language. So we have to discuss what dynamically typed and loosely bound means. We'll come to that, but for the time being, you just refer to a variable in Python, okay, and you don't have to declare the type. Okay, so this is in contrast to what we do in case of C++ or Fortran, etc., where if you want to use a variable, you have to declare the type. So let us go to a notebook and see how it can work. Okay, so okay, so if you simply say equals to 0 in Python, I hope you can see it. In Python, it is a valid statement. Okay, so here what you do is you have your variable, you assign a value to the variable, but nobody knows what is the type of the variable at this point. But that's not true. I mean, Python knows. You don't really care about it. From uh, from Python 3.6, actually you can also use a static type to the Python code. So this is something that I want to tell you, but it probably doesn't really mean much. So the important point is that the type of the variable serves two purposes. One is that you specify the type to tell the compiler that yes, this is the type of the variable and that should not change. And the second is that you also allow the compiler to do the optimization based on the type so that your program runs faster. Okay. Python introduced this static type quite late, as I said, Python 3.6. And most likely, so if I go to this, if I say b int equals to 10, and you see that something is new here, and it should also work. So that means now you are saying b should have a type which is integer. Okay, so you will, once again, if you look at the documentation, you will find that for even for the function which will come to, you can actually define the return type, okay, which is very important. In Python right now, people who already know Python, most of you already know Python, you do def and then define the function, and whatever you want to return, you return. Okay, because you do that, the Python interpreter has to keep provision for anything that you may define return, and that is a loss of optimization. But if you could tell the Python interpreter that no, I only want to return a certain data type, then Python interpreter can remove all other provisions but keep only a provision for that data type, and that will be some kind of an optimization. But still, I don't think, at least I have not tried myself, but whatever I have read, I understood that the Python data type, the static data type which you use in Python, is just as a hint now. It's not really a part of the whole architecture of Python. So but slowly it will become. Okay, slowly it will become, so that you can use the data type optionally. It's as you have already seen, you can write a equals to 0, or you can write also b, then you give the data type. So it's optional typing. If you when you develop your code, you don't have to give the data type, okay, because you don't need it. It makes your code very messy. But after you have developed your project and you want to gain some performance on that application, maybe if you now specify the data type for each variable, Python will be able to optimize it properly, and it will give you some more performance advantages. Okay, so that's why it has been introduced, but as far as I understand, it is not yet fully used. Okay. Okay, so if we don't really take that into account, that static data type is important, then we will not use static data type anywhere else in this course. So the important point is that you can change the data type at will. If you don't specify the data type when you start in the beginning, you can change the data type at will. So once again, let's go there. So I say that a equals to 0. By saying a equals to 0, from the context, because that part is context sensitive, from that context Python will know that I am talking about an integer. Okay, so how do you know that whether it's an integer, or does Python know that a is an integer? Yes, Python knows that it's an integer. So what I can do, there is a default method in Python interpreter called type. If you put a inside type and you press, and you see that it will tell you that a is an integer. Okay, so that is very important. That's very important, and that's why I wrote here that Python is dynamically typed, loosely bound, but it's not a weakly typed language. So there are many different nomenclature for that. Weakly typed languages are those where the interpreter doesn't keep track of the present type of the variable, but Python does, as we will see once more. So now if you want to change the type of the variable, you don't have to actually do anything but assign to a new data type. For example, now I say a equals to 5.0. So essentially from the context, Python will immediately infer that now I am talking about a floating point number. And if I do type of a again, I'll see that it has become a float. Okay, so similarly I have shown you like 6 instances. You can start a equals to false, which in this case false is a keyword. False and true with capital T, they are boolean, and Python has a data type called bool. Okay, similarly you can have integer, as we have seen. You can also have a string. You can change it to a string, and then Python will tell you that it's a string. You can also look at some other data types which will come to. So just to go a little ahead, so this 1 2 3 4 within this box is a list, Python list. So a equals to this will, if you now look at the type of a, it will tell you that it's a list. Similarly, if you keep it open 1 2 3 4 etc., then it becomes a tuple. So there are different data types which we'll talk about, and you have already learned about 5 6 data types here. Okay, so one is boolean, one is integer, then string, and they are, I mean, of course string is a very powerful thing, then list, then tuple. And also Python introduced something, another keyword called none with capital N, and this is a data type called none type. Okay, so altogether this Python that way is a very high level language with dynamically typed, loosely bound state. Okay, so Python design highlights. You know that Python has a huge ecosystem, software ecosystem. I think I mean nobody can even gauge how deep and how wide the Python software ecosystem is, because every day many people are writing so many useful Python software. So for us, the design highlight will be this: Python started with a very modest goal, because if you when it started, I think it started in 1987 or something. Then it started just to do scientific computing, which was known at that time. Okay, and Python did not really venture to all other areas of computing at that time. So it did one thing very well. That means the design. The Python design was such that it should be very simple language, and it should not have a lot of idiosyncrasies, okay, like other languages available at that time. So that way Python slowly gained popularity, but now Python has become a very wide language. So first of all, it supports all major programming paradigms. That means the procedural, we will see; object oriented, we will see; functional, we will see; then imperative and declarative. Imperative means where you write your own logic. That means when you write your program, you write your own logic yourself. Okay, and declarative means you don't write your logic explicitly, but you give some instruction. Okay, so I'm not going to discuss much about it. It's also called symbolic, declarative or symbolic. And when you will learn machine learning, you'll see that machine learning mostly work with the symbolic part of Python and not with the imperative part. Okay, then Python, as I said, has a very simple syntax, and their white space actually counts. We'll see that. Then Python is a pass by reference. This is important because it contrasts to C or C++. Python is a pass by reference. If you don't understand that, maybe I have one example which we will discuss. Okay, dynamically typed, loosely bound, we have discussed. Scripting and driver language we have discussed. Now the other important points is that one can programmatically build and execute Python code as strings on the fly inside a running Python program. That means I have one very simple example. You can actually have a valid Python code which you build from another Python code and execute inside that Python code. So this is a very typical thing. So it's not that if you had C++, then you could not do that, because you would have to compile that thing. We know that with root frameworks like root, you can also do that. Okay, you can also build your C++ code dynamically and compile them and then execute them. Python also does the same. Okay, and it's a very powerful feature, but I don't think today you will understand it. Object orientation from ground up. This we know, Python is an object oriented language from ground up. We will see that even an integer is we will see one example, is an object. Python doesn't have data hiding, which is one of the main features of any object oriented language. Python doesn't believe in hiding data. So it thinks that, okay, people should be behaving well, and they should never expose the data which should not be exposed. Okay, and Python is a very high level language. It's called VHLL because it has support for exception from ground up, from scratch, and it also the introspection, which I don't think I will be able to discuss today, but you should know the keyword, and you can try to learn by yourself the introspection as a integral part of the language. Okay, so with all this, I think we can do some very basic things with Python. And in order to write your Python code, first of all, you have the Python shell. If you have your own Linux, I mean, whatever I will say here, because I don't know much about Windows. So for Linux, you have a terminal, and if you probably you already have Python installed, you just type Python or Python 3, and you get a Python shell. And within that Python shell, you can work, and that is the best calculator in the world, of course. Okay, then there are many other ways that you can use your Python. For example, you can have integrated environment, development environment, or IDEs like the Spider, like the original IDLE or the PyCharm. You can use any of them, and I think both Spider and PyCharms are very good. Or of course today everybody is used to Jupyter notebook. You can do Jupyter notebook also, but you should know that there are more than Jupyter notebook in the Python world. Okay, and IPython I think is the precursor of the Jupyter notebook, so it's fine. For data analysis on the cloud, people, if you have a CERN account, maybe not many of you have CERN accounts, but if you once you will have it, you can also use the swan web.cern.ch. There on the fly, you can also do data analysis. That means you can keep your data on the CERN cloud and use it just on that web service. Okay, so but this will come later, not in this course, but you should know that. Okay, so let me go to slideshow once more just to see what happens. So Python application domain, I think this I'll skip. There are, as I said, the Python ecosystem is too big now, and it encompasses almost everything that you can think about. This I'll share the slides, and you will learn. Python as an interpreter language, you know that I said Python is portable, and Python programs, you don't have to compile a Python program into executable. So what you do is you have the source code where you give reference to your external libraries. If you use external libraries, for example, if you want to do some machine learning, okay, then in your Python main program which you are writing now, you have to refer to the machine learning libraries like the PyTorch or the TensorFlow or even NumPy, SciPy, etc., etc. Those are external libraries. You have to just specify the external libraries in a particular way in that source code. Okay, and somehow Python will know where those libraries can be found. That Python will know. Okay, then what your interpreter does is essentially it parses your code to understand that there is no grammatical mistake. That means they are all compatible with what is expected, and then it will do a byte compilation of that source code. And that is byte compilation essentially will be a string of byte, but with some intelligence so that the interpreter actually can understand what's there. And then you simply run. When I say run, this I have already, and I'm repeating that that means your virtual machine, which is the Python interpreter, you will interpret the byte compiled string of bytes. Okay, then if there is a problem, so this is your testing part, you run and test. If there is a problem, you edit it again, and you go through the same cycle. So this is the life cycle of a Python program. Okay, you are not asking any questions at this point. I think it's fine, but still, if you have questions, please stop me and ask. Portability. I already said Python is portable. Python is interpreted. So we should talk a little about the performance. So Python has a huge performance penalty compared to the compiled languages like Fortran, which you know is fastest. Then you have C, C++, and nowadays Go and Rust. Go are also very, very fast. They are as fast as C or C++. And finally, even Julia. So Julia has not proven that it is always faster than Python, but the other languages for the same task are much faster than Python. Okay. However, we all know that this is the execution speed, and there is also a development speed. That means how fast you can develop an application. And in that front, Python shines. Python is much better, much better than all the languages that I have mentioned there. So, and that's why the benefits of using an interpreter language like Python usually outweigh the lack of performance. But when we come to data science, this is no longer true. You actually need both. You need rapid application development, but you also need the speed. For example, we know that life is becoming complex every day. Your training of the machine learning becomes very complex, and you need a lot of performance, and Python cannot give that performance by itself. So Python tries, this is just for completion, Python tries to give alternative implementation of the Python language, because the Python is written in C. The basic Python we are talking about is written in C. So there are other implementations which tries to actually overcome or address the performance issues, but each of them has got certain limitations. So it's not that any of them is going to solve the Python performance issue soon. Okay, so just to you should know the names. One is called Cython. Okay, Cython is Python itself, but as I said, Python is written in C. On top of that, you you also make sure that Python can directly use C like syntax in the Python code. That means Python, the normal Python, which is very nice and very easy. But on top of that, Python will allow you to write almost very straightforward C++ in the Python code, which is not totally exactly the same as C++ or C, but they are very similar. So that way you can gain performance because you are embedding like C or C++ directly in Python code, which you don't have to interpret at that point. Okay, but this will not keep your, yes, questions. Okay, so in that case, if you do so, your Python code doesn't remain Python anymore. So it is, I mean, not the best option that people think about, but people use it. People use it. Okay, then you have PyPy with just-in-time compilation, JIT compilation. This actually works very well for pure Python. That means if you write everything, if you could write everything in pure Python, even all the machine learning libraries that we are thinking about, TensorFlow or PyTorch or any other JAX, etc., all are written in pure Python. There is no other component. There is no C++, etc. Then PyPy would optimize them pretty well, and they will be faster. But we know that you cannot really write those libraries once again in a programming language like Python. You have to really connect from the Python world to the C++ world in order to use all those libraries. Okay, and in that case, PyPy doesn't work because PyPy is written in a framework which is called R-Python, which doesn't really like C extension. Okay, so PyPy will work if you have small programs which are written in pure Python, and you can speed them up by a factor of 20, 30. But once you are going into bigger projects where you need extension, C extension, then PyPy will not work. So the last one is called NumPy. NumPy is also something which does just-in-time compilation, and it works with some kind of a decorator. It's a compiler, Python compiler, just-in-time compiler. So you have a Python code, it's a very standard Python code, and you find the bottleneck where you need to speed up. So what you do, you have to actually decorate those part of your code with some number instruction, and number will try to JIT compile only those part. Okay, so that you can speed it up. Once again, as you can see, this will make your code at some point very, very ugly, because there will be your decorators almost everywhere. But you can see that these are the way, okay, to speed up Python in order to be in computation. Otherwise, Python will be slowly, as the data volume increases, as your requirement of computing increases, Python will slowly lose its importance. Okay, so now I think this one, many of you already know about Python, so I don't have to go through a lot of things. So one important point is that if you start Python on the terminal by typing Python, so you enter the Python shell, and then you might be at a loss to find out how to get out of the shell. Okay, so there are quite a few. So one is Control D. You can type Control D, or you can say quit. Okay, quit a function, so put the parenthesis also, the brackets also, or you can say raise system exit. That means you are raising an exception which will exit from the terminal. And the fourth one is that you can import a module, import sys system module, and you say sys.exit. So there are 4 ways in which you can actually exit a Python shell. Okay, and in the first part, you can have a lot of things like a Python. You can look at the credit, you can look at the copyright, you can help on few things. So the one good point of Python is that Python is a language which integrates the documentation also inside the software itself. So sitting in the Python shell, or I think IPython or notebook or even the IDEs, you can get all the information about your running objects. Okay, so this you can find out. You don't have to really go to Google to do that. I mean, the basic information you can get sitting in the shell itself. Okay, so as I said, Python is the best calculator. These I am not running on the today. Mostly, I'll not be running much on the notebook because these are simple stuff. So first of all you know that there are two major versions of Python: Python 2 and Python 3. And now, due to machine learning, everything has been implemented in Python 3, and so Python 2 is not anymore used in the scientific world. So everything has to be Python 3. But if you have Python 2 and Python 3, then they are now explicit. Most of the modern operating systems, at least Linux, Python 3 is the default, and Python 2 you have to really install as Python 2 and execute it. Okay, I think there are for Linux, Python is also the language for installation. That means the backbone of a Linux system is also Python, and some part could be in Python 2, and mostly in Python 3. So at some point, everything will be ported. Many operating many distributions, everything has been ported to Python 3, and there Python 2 is not installed by default at all. So you have to really install it by hand. Okay, so Python now comes how do I use the calculator? So people who don't know it, so let's look at some of the examples. For example, I want to look at a power. That means, so in C there is a function called power 2 to the 3. Okay, I want to execute that on Python. So I write it and I execute it, and it gives me an error. But here, for example, it will not give me an error. So there is a confusion that the notebook by default actually imports a few things so that it will execute. On the other hand, if I go to a shell, just to so this you have to keep in mind. So when I talk about it, also it is important. So for example, if I type Python 3, I go to Python 3, I do 2 to 3. Oh, no, maybe it's Python 2, Python. Okay, for example, I don't have Python 2 now. So this is not the right example. So let me find another example. Uh, Import math. Okay, I'll explain that. So in Python language, when you start the interpreter by typing either Python 3 or on the Jupyter, is a very small one. So it doesn't load a lot of things. At least in principle, I mean, classically, it doesn't load a lot of stuff. Okay, so what you have to do, you have to import some module in order to get some facilities. One such module is called the math module, which is exactly the same as the C math module. So in order to get, for example, log or something, we can now see log of 10, for example. What happens? And you see that log of 10, it says the log is not defined. Okay, so also I think in the notebook I can do that instead of PWO. Maybe it was a wrong example. So log of 10, it says that name log is not defined because in the environment, running environment of the Python interpreter, log as a function is not defined. So where is it? So you have to do import a module math, which is the module name of the module, and then if you say math dot log 10, it should now work. Okay, so that is a very important concept, that most of the facilities, most of the software in Python are kept in different modules, and in order to access them you need to get the modules, and there are many different ways of getting those modules. If you don't want to use the math.log at all, what you could do, import from math import log, you could do that. Okay, and then you could simply say 10. Then so what you have done is, from the math module you have imported the keyword called log. Now we know that that keyword is actually a function. If you say, no, I don't want to remove math dot at all, but I want to replace math with a shorter keyword, so you could say import math as m. That is also a valid one. Then you could say m.log 10. This will also work. And finally, if you want all the symbols from a module to be available in memory, for example, your log is here, but if I look at some other, for example, if I look at floor, what will happen? Let us see. I have done floor of, let us say, 2.3, and you see that again it says the floor is not defined. So then I have to do m, either math.floor or m.floor 3.2 or whatever, and it should work. If you are really bored about all these things, you can also say from math import star. Okay, from math import star, if you do, and then if you do floor of 3.2, it will work. Okay, so there are many ways that you can import your symbols, the required symbols from certain modules. So if there is another module, for example, we saw already an example of sys module, sys, and if in order to exit from the shell, you say sys.exit. Okay, so essentially you should never do this. This is the most important part, because we know from the math module that there are only few symbols, but there could be a module with thousands of symbols, thousands of functions, some global, some constants, etc., etc. And in that case, your environment will load all those symbols directly, and maybe you will be using only one or two out of them. So then you should selectively import only those symbols which you need. Okay, or you simply import the module, and then you do module name dot that functionality. So all of them are actually shown here, that you can simply do import math, then you can say math.log, or you can do from math import log. You can put a comma here and also put all other symbols that you want to. For example, I could say floor here. That should also work and then you use both log and floor without any specification. So module in Python is called a namespace. We will see in a single module actually can have a lot of symbols. Even classes, Python classes, when you talk about object orientation, you'll see, can also be a part of a module. Then you import the module, and from the module you import the class, and from the class you instantiate an object, something like this. So the procedure is the same here for math, because everybody knows about the math module in some sense, so it's easy to show what we expect. So once again, just to repeat it, you try to always avoid importing everything. You will see in others code that people do that, but that is that is not something very of course it's not advisable at all, and that might also create trouble. But even if you forget about all other troubles, at least from the memory point of view, you don't want to put a lot of symbols in memory which will not be used at all by your system, because either you put a lot of pressure on your garbage collector and so on. Okay, so this will keep in mind. Python is a calculator. This we have already discussed. It's not only interactive Python that is the that is the norm. So there are also other ways of executing Python. So the most basic one is to put your Python code in a file and execute them with the Python interpreter. So that's the first thing that you will do. In order to do that, I will just show one example. And as you can see, this you cannot really do on the notebook. Okay, this is something which you have to do on your shell. So let us open a shell. I have the shell here, so I quit. So I want to write, just take that example from here. Okay, what I'll do is I'll take like test.py. Let us say this is my test.py, and okay, not this one. Okay, test2.py. So what we have done here is just we loop over something. We loop over the range and print it. So this is what I will do. So for I in range, let's say 10, and this is the syntax. I am not really going through the syntax of Python. I'll just show you. So I, okay, so if I do that, so Python, and you can see that it runs. It gives me, so there are quite a few things that you can see here. First of all, you have a for loop, okay, and you have a function, inbuilt function, because you don't need any module in order to do that. Inbuilt function which is called range, and if you pass a value, an integral value to that, it will start from 0 until that value -1, and it will create a range for you, range of the list of numbers for you. Okay, so this automatically you will be able to iterate because it's a for loop, and you see that I will be assigned each value in turn as you iterate over the whole range. Okay, so a lot of things are happening here, and then you are just printing the value called I. Okay, and you are putting a gap, but of course it is not working. Okay, this I have to see. But important thing is, let me first discuss the important part. This, I want to now understand whether this is Python code. I know that I have given a name test2.py, but is it a Python code? How does the shell, the Linux, I'm talking about Linux, with Windows it might be different, or Mac it will be the same as Linux because they are both Unix. So for how does the operating system recognize this file? Is it a Python file? Let us see. So how do you know that? In Linux there is a tool called file. There's a command called file. So if I do test, if I pass test2.py to the command called file, it will tell me that it's a text file. It doesn't find it that it's a Python program. It simply says that test2.py is an ASCII text. That means it's a text file. Okay. I'm not happy because I want this file to be recognized as a Python program. So how do you do that? So you open it again and you add a magical line. It's called hash bang, then user bin env. So there is a tool in Linux again, once again, Linux is called user bin env, and you put Python here. So this is one line that you add as the very first line of your program, and without any gap, you have to do this. Now let us see what happens. Now let us see if I again test the type of the file, and you see that now it's called a Python script. It's a Python script. It's an ASCII text executable. We know that a Python program is already an executable. If you pass it to a Python interpreter, it will be executed. So if you, whatever you do on the can do on the Jupyter notebook, probably you will do for the most of the machine learning stuff you will do on the Jupyter notebook, but there will be all the other stuff which are not very useful on the Jupyter notebook, or they are long running stuff, okay, that you will try to put in a file and run it with the on the shell with the Python interpreter. And in order to do that, you can actually put the first line there. Now you will ask me, what is the point of putting the first line if I execute it like this? If I execute it like this, what is the point of putting the first line? Because I am anyway putting the Python interpreter. So, and the Python interpreter will find out that this is a Python file, it will parse it and execute it. I would like to also run it as an executable like this, like other executables, C executables. Okay, and the operating system will automatically know that it's a Python executable and it will do whatever it is needed. And you see that now it is not working because it is simply saying is permission denied. So what I will do, I'll do chmod. There is another in C in Linux. There is another command called chmod, which will change the execution bit of this file. So I'm adding an execution bit which with plus x. I'm not going into the detail, but now it will not say it's permission denied, it will actually work. So this is one way where you take a Python program, a long running Python program, and you put a in the very first line, that magical line that I have already discussed, and you just turn on the execution bit, and then it becomes like an executable. Although it will not be faster, I mean, just by doing this compared to what you do interpretation, it will still be interpreted, but you don't have to write Python all the time in front of it. So it's up to you whether you will like it or not. If you want to always write Python in front of the name of the executable when you execute it on the terminal, then you don't need the first line at all. Okay. Okay. So this is another thing. Then Python has also, if you have this file, if you have the simple file, Python, inside the Python interpreter also, there is a command, inbuilt command called exec file. You can exec that. Okay. So this is another thing I can show you. So I'm here, I start Python, okay, and I have test2.py. I can do exec file, and within quote, because it's a string, I just give the name of the test2.py. And this exec file is not defined. Okay, so then forget it. This probably is old one. This is probably, I have to find out. This may not be there at all. Okay, then, sorry, this one I gray out for the time being, because this is Python 2. With Python 2 this works, of course, but I don't have Python 2 here anymore. So then there is a very important one which is called eval. Eval is a very important one. As I said, that one of the main features of any high level language is that you, within a running program, you can actually build another program, okay, and execute it. And when you build another program, means you just build a string which is valid as a Python code, and then you just say eval and or exec. There are two things, exec, and you pass that string, and it will execute it. So a simple example will be that you have eval, and you see that you are passing 1 plus 1, but added as a string to eval. And what Python does is it will actually take the string, it will parse it as if it is parsing your file, and it will return the result to you. So this I probably can show you. Result equals to, because eval should work. So 1.5 plus 3.14. Okay. So this will, now if you print the result, and it will print something. So this is, I don't know whether you are following this one. This is a very important feature, because from a running program, within sitting in a running program, this is my Python shell. That means I am sitting in a running Python interpreter. And I am executing it dynamically. Okay, and this is a very simple one. You can think about anything which is any complex thing, it will still work. Okay. For example, the next one will tell you that I have a hello world. Okay, I have a hello world, and you can see that you want, okay, so maybe this is not more complicated than this is still the same. Okay, so these are other examples, it's the same. So len, this is just to show you that there is another inbuilt function called len, which tells you the length of a string. So hello world is a string here, and len of hello world is the length of the string. And what you are doing is you are doing an eval. So you could also, if you have hello world, for example, I could do this, so it may not be very useful. So hello world, so it will give you 12, but I could also put within quote. Okay, so it becomes a string. If you type it, it will not give you 12, it will give you just a string, because it's just a string. I can i can take this string a equals to this. So a is a string now, you can see that a is a string now. So it's a string. Now suddenly I do eval a. It was a string, but it's a valid Python string. That means it's a valid Python statement. So if you have a valid Python statement and you execute it with the function called eval, then it will actually interpret it and give you the result. Okay, so this, I'm, as I said, for completion, this probably you will not need much in your Python, in your life with Python, but you should learn on these things, that Python has such very important and useful features, which sometimes you may need, but if you don't know that they are there, you won't be able to use it. Okay. And the last one is exec. As I said, if you write a code, is similar. You can see that you have print hello world. Once again, is a string. You can just write, and then instead of eval, you do an exec. That will also that will also give you the same result. Okay. There are some difference between eval and exec. I think one of them may you may actually hold a value inside the code that you dynamically generate in case of exec, and in the case of eval you just return it. Okay, I think these are the only difference, but you can continue to use eval and not use exec at all. Okay, so I think I'm coming close. So data type, now we are going into the important part, data type. Then you have variable scope and namespace. Once again, when you learn Python, at least the variable scope, I'm pretty sure that you miss the main thing. And the one
Sir,
of the good, yes, please.
sir, so as you said that the eval function basically executes a smaller Python code within the Python. So does that, I mean, speed my code up? Like instead of def, can I somehow use eval to execute the main program faster?
No, eval, to me the main purpose of eval is that if within a Python program you need to dynamically, like you bifur, you say, let us say you have a Python program, okay, and you have a definite path through which you want to go. Okay, but eval will give you an option also to suddenly take a different decision and go totally somewhere else, which is not there in the static code which you have developed. Okay, so what you will do is that in that case you will dynamically, as another alternative, you will dynamically write some code at that point, sitting at that point, and execute it. But this execution you cannot do, because when you create code dynamically, you are actually just adding some strings. Okay, you when if you develop some, for example, I mean, whatever you write in your Python file is a string. So the Python interpreter takes the string, parses it, interprets it. Similarly, the Python interpreter can also take dynamically within the running Python interpreter some valid string and interpret it. But in order to do that, you cannot just develop that code and say execute. You have to write, I mean, execute it through some function, and that function is called eval. which will use the same interpreter and evaluate. So it will not speed up anything. It will only give you another alternative path if the static code which you have developed in order to do your, in your application satisfies all your needs. If all your needs are not satisfied, then you may have some alternative path which you dynamically generate and execute.
So, sir, this is just, this is just running another Python program and nothing more.
This is not running another Python program, but the same Python interpreter will now stop its execution and the normal execution and execute it. Or yeah, it may also, if it's needed, it may spawn another Python interpreter and interpret it if it is outside of the main thread. But if it is in
Okay.
the same thread, I can, okay, not today, but maybe tomorrow I'll share one example where you can actually do useful stuff with eval. Okay, I don't have any example right now, but I didn't want to really spend a lot of time on this, but now that you are asking, I will find a way to do that.
Okay, sir.
Okay,
So I
so
have one more question
yeah,
on.
please go on.
So when you did this exercise in your terminal, you tried to eval some 1.5. This
Huh.
one. So there you add 1.5 plus 3.14, but towards the end there is something showing 1. So why it is coming?
Okay.
4.64.
This, I mean, for, because you are, let us say, what is this? This is 1.5, and so type of result is what? Should be a float. And you see that Python also does a lot of stuff here, no? Which we have not. So you pass Python the eval function two values, which are floating point values. So
Mhm.
Python knows that the output also will be a floating point value. Okay,
Yes.
but this floating point value, the Python sum. So this is one of the one of the limitations of almost any languages, that when you sum them up, you cannot really keep the precision correct, because when you sum up, they are 32-bit floating point numbers. They are not 1.5 or 3.14 when you are summing them up. So they will be considered as two floating point numbers. Do you understand that? So 1.5, when you pass 1.5, so Python considers the 1.5 to be a floating point number. And it will also consider 3.14 to be a floating point number.
Yes.
So that way, if it's a 32-bit number, the precision, it may not be able to keep the precision at 1.5. Similarly for 3.14. So when you add them up, that is why for the floating point number, it is always advised that you don't try to check the equality of two floating point numbers, because the two floating point number precision may not be always kept the same way. For example, if I say 3.14 and b equals to 3.14, and I say a equals to b, okay, so it is true. But this is not always the case. Okay, if you do some operation, it may not be the case. How? That is why I cannot, I mean, right now I cannot explain why the one has come, but all I can say is that when the summation was done, it was not done in terms of 1.5 plus 3.14. It was first expanded into a full floating point number, 1.5. The 3.14 was also expanded to a full floating point number with 32-bit. Okay, and then the bitwise summation was done. Now, while doing this, how Python manages is something that I don't know. But that is why people say that you, for languages like Python, there are few languages where they actually make sure that when you compare two numbers, they should be exact. They should exactly match. But Python doesn't do that.
Okay.
Okay, so once again, maybe if I have a better explanation, I will try to do next time. I don't have a better explanation than this right now. Okay, so we have already looked at the data types. One is number, which we have seen. including complex numbers. Then you will see here, for example, this one 999L. L is that it's a long integer. So if you want to look at the long integer, then you put an L here. We can see that. So if I do L equals to 999, then L, sorry, why? This will be integer. I have to see whether I typed it correctly. L1, if I do U, will it work? No. Invalid decimal integer. Just a moment, let me just check once, because syntax. Literal Python. So I think most of my code are for actually Python 2, and in Python 3 there are some changes. Once again, I have to correct myself. This one, sorry, that I'll do this one. This L, I think I have to correct. I have to check somewhere. So I'll come to that. First, let me just finish it. Then we have seen the string, we have seen the list, which will come to all of them, and the others we have also checked the tuple. The other two important data type, one is called a dictionary. Okay, dictionary you have to explain. Dictionary means it's like a phone book. You have the name and the phone number. Okay, so the combination, the pair. So it's called the key value pair. Key value pair is like, for example, compiled is Fortran and C and C++. Interpreted is Perl, Python, Ruby, and you see a comma here. So there are two pairs actually. In the first pair is the compile is the key, and Fortran etc. are the value. And the second pair you have the interpreted, which is the key, and these Python, Ruby etc. are the value. And you see that key pairs are separated by colon, and each pair is separated by comma, and also they are demarcated by the parenthesis. So in Python, if something is demarcated by parenthesis, in principle it should be a dictionary, and they should have the syntax like what is given here. For example, in the case of list, I told you that the list should be demarcated by the brackets. Okay. And here it's a very complicated one. You see that there are nested list. For example, you have 1 and comma 2, and the second element itself is another list. Okay, and then 4. And you also see that in this case you have different data types in the list, which is an interesting thing, which usually we don't do for performance. So in the case of Python list, usually we try to use the same data type, but it's nobody prohibits you to use a different data type in a Python list. Okay. While in the case of tuple, actually tuple, you don't really use tuple for any scientific work. It's mostly for other kind of work. So there you are allowed to use different data types, and it's for that. So for example, in the case of tuple, you have 1, then you have world, which is a string, 3, 4, etc., etc. Tuple has two ways of specifying. You have two ways of specifying a tuple: either an open one, or you put the first bracket. Okay, that is also true. And then finally you have the sixth one, which is very important. It's called the file. We'll talk about file also. Okay? So these are the 6 data types with which Python can work, and these are built-in data types. That means all of them except for the L, which I think from Python 2 to Python 3 has disappeared somewhere, or it has changed. I have to find out, and I'll correct it on my slides sometime. Okay, so now before stopping, I'll talk a little bit about the scope and the lifetime. So scope and lifetime is very important in a programming language, because as your program grows, you lose track of the variables. Okay, so the suggestion is that you try to make all the variables as local as possible, so that they don't overflow their scope. That means a variable, you use a variable, when they cross their scope, they are not needed, they should be reclaimed by the system. Okay, and if you want to reuse it, you will reuse it, you redefine it again so that they will reappear. Okay, so how does Python do? So the definition of the scope is the part of the program where a variable is accessible. Okay, and lifetime during not duration for which a variable is accessible. These are the lifetime. This, I think, is a very general statement, and you understand that. So in general, variables defined in the main body of the program have global scope. That means if I write a program 10 lines and I put a equals to 0 in the first as the first line, then everywhere a is available, a is accessible. A only goes out of scope when the main program goes out of scope. Okay. So that's what it is written. Global scope is usually a bad idea because you don't know throughout your code. If you have changed the variable, the value of the variable, then you have to keep track of exactly what you did during the change when you change the variable. So inside a function, a variable should have local scope. That means a function, a variable which you define as a function parameter should not be available outside the function. I think everybody agrees to that, and you will see how Python does. In a class, in a class, a variable in a class have local scope but can be accessed from outside through the object. This will come later on. For the timing is not needed when we will talk about Python. But anyway, Python, because Python doesn't have data hiding, the question of this line is irrelevant for Python. Okay, this question actually doesn't arise. So the first two, let us look at this example. Okay, and you can answer. So a equals to 0, and if a equals to 0, b equals to 1. Okay, so if you have learned some language, okay, then you should be able to answer what you expect when I try to print b. Can somebody answer what print b will be and why it should be, whether you like it to be like that? This is in Python. If I write the same thing in C, then we will also see C++ or C. So the Python, to me, one of the drawbacks of Python is that Python doesn't carefully implement the scoping rule here. That means a equals to 0. That means if I do if a equals to 0, this is true because a is equals to 0. Then b will be equals to 1. Okay, and then this b, when you print b, actually you will print 1 here. Now the question is, in C++, this will be a compilation error. C++ will not compile because it will say the B is not available here at all, because B was within another scope. We know that anything you do like this, like if statement, it actually creates a new scope. A function will create a new scope. A for loop will create a new scope. Even just by putting two parentheses will create a new scope, but not in Python. Okay, so this is one thing you have to watch out for. That means this B continues to live. I can show you if you even here. So I think this is better we do. So a equals to 0. So if a equals to, I compare it, then I do b equals to 1. Then I do b, and you say b equals to 1. If I now do another one, a equals to 4, let us see what happens. I've never tried that. No. 0, c equals to 1. What is c? And you see that c is not found. So this is something which is slightly misleading to me. That means if you somehow can access a variable within some scope here, that variable continues to live. that variable continues. If you cannot access that variable, of course, you don't have access to that variable. So in the second case, because I have put a equals to 4, that means I never reach this statement. Because I never reach this statement, then C is undefined. But because in this case, I reach B equals to 1, then B is accessible. But in principle, because to me, or like C++ from somebody who came from C++ or Java or other languages, that this has created a local scope. So the variable which is created within that has a local scope. As you can see, B is not available before that if statement. So this is a local scope, and in principle, B should also go out of scope as soon as I come back from the if statement. This will be true for C++. So this is one very big difference between C++ and Python, that the variable B continues to be there. And this to me is something that they should have done better. On the other hand, for the function, the local scope is exactly the same as C++. So on the right hand side, you have another example. So you know that function is defined with a keyword called def. So def test underscore scope, and you have a variable called C. You put D equals to 3 and you print C and D. Okay, this is fine. Let me just copy it here. See whether I can do it. So what happens? I think now you have got the idea. Def test scope, and I just pass C here, and I put D equals to something. I don't remember. D equals to 3 and then I print C and D. Okay. Okay, this is my function. Then I put D equals to 5 and D equals to 5, and I say test scope 7 and see what happens. No, tests. Oh, I put the wrong name. So test scope, and you see what happens. I have passed C, which is 7. So it prints C to be 7. And you see that D, I assign D to be 5 before calling the function. But D within that function has a local scope. So that's why it has printed 3. So it did not take because, or you can also think in terms of reassigning the value. Okay, because I have reassigned the value to be 3, it has printed 3. Now I am out of the scope. I'm out of the scope, and I will again try to print C and D. What will happen now? What will happen to C, for example? Anybody? Okay, so as I said, Python does the local scoping part correctly in case of functions. That means the variable C is local to that function, and it is not available in the main at all. Because it is not available in the main at all, then this line will actually fail. This line Python will fail. In my case, it may not fail because I have already defined a C there. Okay, so I have to unfortunately, because I had this C. No, this is not available. So let us see now. Instead of test, I just want to print now C comma D, and you see that it says C is not found. So if you go back again here in the if block, if you have, once you have assigned B, it continues to remain alive, and if you print it, it prints. But in the case of C, which is which is a part of the function, this is local. As soon as your function is out of scope, the C is also out of scope. So C is not available in the main scope anymore. Okay, that's why it is giving me that in the error that C is not defined. So this is something which is slightly peculiar in Python. The right hand side is correct. I mean, when I say correct, it's compatible with C++, but the left hand side is not. So whenever you write Python code and you use global variable, you have to keep an eye on that. Okay. So I think I am already over time. So I'll stop here today. As I said, once again, I will give this disclaimer that for many of you, these are all known. Okay, but I still wanted to make sure that the very basics are covered well in the first two lectures. So in the afternoon, we will try to cover the rest of the very basic stuff, and then from tomorrow we'll try to pick up